The other protocol is IPv6. IPv6 is also known as Next Generation TCP/IP. It was developed in relation to some of the shortcomings of IPv4. When IPv4 was first developed, I mean, technically TCP/IP was developed back in the late 60s. I'm not sure the exact year IPv4 was finalized, but it was at some point in the 80s. You know, at that point, a 32-bit binary address, that seemed like it would be fine. I mean, that's 2 to the 32nd power, which is 4.3 some odd billion addresses that was going to give us. And everybody thought, well, that'll be fine. Well, it became very clear very quickly when the internet, you know, started to blossom and the World Wide Web launched, that we were going to run out of addresses, and we were actually going to run out of addresses pretty quick. By the late 90s, we were starting to be very, very limited on the number of addresses. And so IPv6 was developed primarily to deal with that, to provide a larger address space. Now, mind you, we've actually been able to sustain the use of IPv4 for many, many years beyond what was originally expected through the use of private addressing and network address translation. I read a book back in 2002 or something that said that we were going to be completely IPv6 by 2015. Well, here we are, and most internal networks still don't use IPv6. It is now used out on the internet. We now have officially run out of IPv4 addresses. It's been supported in the Windows operating systems for over a decade, but at the same time, most of us have still not encountered it a great deal on an internal network. That is going to change. Of course, I've been saying that's going to change for 10 years or more, but now we are nearing the end of life for IPv4. So IPv6 has a larger address space. It's built on 128-bit addresses. It uses hierarchical routing and addressing to be more efficient. It's more of a globalized routing where different regions of the world basically have a set of addresses, and so it makes it easier for the internet routers to route effectively. There is automatic configuration like DHCP, but you have stateful and stateless. Stateless means that the nodes can configure themselves automatically without having to communicate with a DHCP server. So it's actually more simplistic. The configuration is more simplistic than would be available in IPv4. There's required support for quality of service and IPsec. These are extensions to the packet headers to include things related to security, which is IPsec, and related to prioritization, which is quality of service, which is important on converged networks where you have audio, video, and data traveling on the same pathways. Some of those are more time critical than others. And it reduces the need for network address translation in many cases. Windows 10 fully supports IPv6. It's installed by default. It's installed in a dual stack architecture, so both IPv4 and IPv6 are running side by side. It is required by some features. It is utilized by some Windows services, especially for internal, local area network connections. But for the most part, it's kind of behind the scenes. You don't really see it a lot. You don't have to do anything with it necessarily. And that necessarily is based on whether or not your company is actually implementing IPv6 internally. The IPv6 addresses are something that we want to understand, though, just in case we encounter them. As I said, they are 128 bits in length. So you thought 32 bits was bad, 128 bits, that's a whole lot worse. We're not talking about 4 times. You say, okay, well, it's 2 to the 32nd, so 2 to the 128th is 4 times that. No, it's not. That's not the way a base 2 numbering system works. Remember, 2 to the 33rd power is twice that of 2 to the 32nd. And 2 to the 34th is twice that of 2 to the 33rd, or 4 times, so on and so forth. 2 to the 128th power is almost an inconceivable number. They've come up with other ways of writing it that just make a little bit more sense. But it's just an astronomical number that we probably will never reach. I know they said that about the 4.3 billion, but you could, if you really tried, you could probably count to 4.3 billion. You can't count to 2 to the 128th power. So we have 128-bit addresses, and because they're so long, they decided to write them in hexadecimal. The reason is every 4 bits of binary can be represented in a single digit of hex. And so it shortens the numbers, or shortens the number. I mean, you still have 8 groups of numbers, 8 groups of 4 numbers, but in hex that represents 16 bits for each of the 8 groups, total of 128 bits. Okay? You may not see all 8 groups populated like we do here. There is the ability to eliminate leading zeros. Okay? So in our address here, we've got 2D or just D in the second group of numbers. Well, that just means there's 3 leading zeros in front of that. All right, but they've been compressed. If you have multiple groups of zeros, then they can be compressed even further, and you can just show double colons. There are fixed address types, so therefore there's no subnet mask involved with IPv6. You just have prefix links. So like, the link local addresses all start with FE80. They all have an 8-bit prefix. They just look the same. Your public addresses all start with 2 or 3. Generally have a 64-bit prefix, dividing it in the middle. It's a fixed address type. And so it's more efficient in that way. It's more efficient in routing. It's more efficient with prioritization. There are several different address types that you have with IPv6. The ones that you will predominantly deal with, if at all, would be the unicast addresses. Unicast is one-to-one type of communication, and there are a couple of different kinds. You have the global unicast. Global unicast is the equivalent of a IPv4 public address. Some of you, at home and maybe in business, but especially at home, because your ISP has switched over to IPv6, you may see this. Okay, if I do an IP config on my system on my home network, I see a 2601 IPv6 address, and that's just because my ISP has started giving those out. Link local addresses, as I said, always start with FE80. That's used for local communication. It's sort of like the APIPA addresses, the 169.254s of IPv4, which you really only get if you're unable to communicate with a DHCP server. So it's just for link local communications. It's not a private address in, like a 192.168.1.200. No, that is called a unique local address. And the only that's actually the only address that you would probably statically assign, because that would mean that you were actually using IPv6 internally. And so you would either set up a scope on a DHCP server, or you'd statically assign addresses on a client. Then you have multicast and anycast. These are both one-to-many. They just have a slightly different purpose. And they are automatically assigned. Those are not address types that you would have to deal with if you were using IPv6. One more note on the auto configuration. It is possible to automatically configure a host with an IPv6 address like you could with an IPv4 address. But there's 2 kinds of configurations. There's stateful, and then there's stateless. Stateful uses both DHCPv6 servers and router advertisements. A DHCPv6 server is a Windows Server 2008 or later machine that's functioning as DHCP with that role installed and has an IPv6 scope set up. So it's prepared to divvy out these addresses on an as-needed basis. Okay, but what happens first is the node starts up, generates a link local address, remember that was the one for private communication, and then talks to the router. And then asks the router, hey, what subnets are we connected to? What address should I get? The address has a little managed flag that's set to on that forces the router to tell the client to go contact DHCP. DHCP will give you an address, and DHCP will give you some options like DNS server, default gateway, those kinds of stuff. Okay? Stateless is the auto configuration that occurs only through router's advertisement. And that's the simpler one. I mean, it's simple because you don't have to have a DHCP server, but it's limited in that it can't provide all the options a DHCP server would provide, all the additional configuration options. And so that's why the stateful method is preferred if you're going to be using IPv6 internally.